My screen must be visible now, right? Is it?
Yes, sir.
Okay. Let's understand about the vectors firstly. What do you understand by vectors? Vector means what? What it represents? Tell. Hello.
Yes, sir. Vector is a quantity which has direction as well as magnitude.
Very good. So magnitude plus direction. Whenever any physical quantities have both magnitude and direction, we use a vector to represent them. Okay, and those quantities are called vector quantities. Some quantities are called scalar quantity, which have only magnitude. So scalar and vector, which generally comes in physics. Okay, this is very clear. Can you give me some example of scalar and vectors? Scalar quantity and vector quantity.
Sir, like real life examples.
Yes, any the quantities you can give, like the speed, velocity, distance, displacement.
Uh, um, Sir, force,
Force is what? Scalar or vector?
velocity, vector.
Vector is force. Why?
Sir, because it has both magnitude and
And
direction.
direction. You apply some Newton of force in particular direction, right? There is
Yes, sir.
velocity also. Okay. And for
Sir,
scalar,
acceleration.
yes, acceleration is also a vector quantity. And for scalar,
Sir, temperature.
temperature scalar quantity. Yes, we can say temperature.
Yeah, and speed
Yes, speed, distance.
and mass.
Yes, yes, yes. Okay, so we have some idea that what we particularly discuss in vector. Now the next thing is how to represent vectors. Vectors are represented by this kind of arrows, right? This kind, where its length gives us the magnitude. This is the length. Suppose I write it as AB vector. This length is magnitude. Okay, length represents the magnitude, and this particular arrow, or say the direction sign, gives us the direction in which it is applied. Okay, if we have
Yes, sir.
an object of mass m and we are applying some force of 10 newton in this particular direction, I think my voice is getting repeated. Hello, what you did? Hello, now it is okay.
Yes, sir.
Yes, force is 10 newton. What we can say that 10 newton is the magnitude, and this particular direction is the direction of the force. Is this clear?
Yes, sir.
Very good. So we have idea about the vectors, and it is represented by this. My voice is getting repeated. How? Check it.
Sir, I think I should mute my mic.
But when you started, it was not repeating. In between, just few seconds back, it started. Hello.
Yes, sir.
Okay, mute your mic. When you have to ask. Okay. Okay. Let's go further. If we have a vector as AB and we have a vector as BC, and we know that BC has two times magnitude of AB vector, we will represent it like this. if we have a vector AB, I can write it as AB vector and will make a BC vector like this. Why? Because the length gives us the magnitude idea. So if AB is smaller, BC is bigger, so we'll have to make BC as bigger. Is this clear? The length gives us the idea
Yes,
about
sir.
the magnitude. Okay, note all this. Is the basics of vectors. Have you taken the notebook?
Yes, sir.
Okay, note. If this length is L, this should be 2L. If it is 3 times, if this length is L, this should be 3L. Noted?
1 second, sir.
Okay.
Done, sir.
Now there is concept of unit vector. We have discussed that every vector is represented as AB vector has two parts. One is magnitude and another is direction. Magnitude, we have connected it with length, and there is concept of unit vector which gives us the direction. Direction is always given by the unit vector. We'll discuss in detail about the formula for unit vector, but let's see first. If I have x-axis, y-axis and here somewhere z-axis, okay. Along the x-axis, the unit vector is what? Answer?
Sir, I.
Yes, I cap. Along the y-axis, it is j cap, and along the z-axis, it is k cap. Similarly, if I go negative side of the x-axis, I can write it as minus I cap. But the important thing is, along the x-axis, we take the unit vector. The direction is always in terms of I. In the y-axis, along the y-axis, the direction in terms of j, and along the z-axis, the direction in terms of k. Clear? That means any vector, if I write, it can be written like 2I plus 3j plus 4k. It can be written like this. It may be possible that j and k are 0 and you can get any vector as just suppose 5I, this kind of also. Here there is 0 magnitude along the y and 0 magnitude along the z, but there is 5 magnitude along the x. Is this clear?
Yes, sir.
Okay, so if I am writing AB vector as 2I plus 3j plus 4k, this means what? 2 magnitude along the x-axis, 3 magnitude along the y-axis and 4 magnitude along the z-axis. That's it. If you are clear up till here, we can go on discussing in detail about how to find the magnitude and how to find the unit vector. Note this part. Every vector AB has two parts, the magnitude part which is represented as mod of AB and the direction part which is represented as cap. Unit vector. Done?
Yes, sir.
Okay, very good. Now let's go further and discuss the magnitude. Magnitude of a vector. How to find magnitude of a vector? If I have a random vector as ai cap plus bj cap plus ck cap, and I want to find magnitude of this r vector, what I'll do, the method is a square plus b square plus c square. For example, if I have r vector as 2i plus 3j plus 4k cap, and I want to find its magnitude, it will be what? Root of 2 square plus 3 square plus 4 square, and it is 4 plus 9 plus 16, which is root 29. Correct? Clear? A doubt?
Yes, sir.
Now let's try to connect it. If we observe in 2 dimension, there is a vector, suppose this is your r vector, and it has ai plus bj. I'm not taking in 3 dimension, because in 3 dimension it will be very difficult to just show it on 2 dimension, because we have plane only. So if we have r vector as ai plus bj, this particular part would be a units in terms of x axis, and this will be b in terms of y axis. Can we take like this?
Yes, sir.
Definitely. And as I said, magnitude is what? Length of the vector. If it is length of the vector, then a and b, this is obviously 90 degree. This particular length would be what? Root of a square plus b square. So what we can observe here? We can observe that if we have to find the magnitude of any vector, we have to just square and sum it and just take the root of that part. Are we clear that why we are taking just the roots? Because we are finding the length. Clear or doubt?
Clear? Doubt. Clear, sir.
Very good. Note this. If I take some example like this also, suppose I have 2 minus 2i cap minus 4k cap. Then what I'll do, I'll firstly convert in terms of properly ijk. This is minus 2i plus 0j cap minus 4k cap, and I know a is minus 2, b is 0, and c is minus 4. So the magnitude would be root of minus 2 whole square plus 0 whole square plus minus 4 whole square, and we'll get 4 plus 0 plus 16, which is root 20, and root 20 can be written as what?
Sir, 2 root 5.
Very good. 2 root 5. Very good. Note all this. So now I think you are very clear with the magnitude concept, that how it is connected to the length of the vector, and why we are doing root of a square plus b square plus c square. If it is in 2 dimension, we'll do root over a square plus b square. Noted?
Yes, sir.
Very good. The next important concept is direction of a vector. As I explained earlier also, that unit vector gives us idea about the direction of any vector. So direction of any vector is given by its unit vector. Unit vector along the x-axis is I cap. Along the x-axis the unit vector is I cap. Along the y-axis it is j cap, and along the z-axis it is k cap. We are very clear with. But suppose we have AB vector as 2i plus 3j plus 4k cap, and I ask you to find the direction of this vector. It is very clear that 2 units towards the x, 3 units towards the y, and 4 units towards the z, but in total there should be some direction, no? Right? There should be some direction. So what is the method? Unit vector says, are you getting?
Yes, sir.
So unit vector says if we have to find AB cap, do what? AB vector by magnitude. Vector by magnitude. So formula is unit vector is equal to vector by its magnitude. That means AB cap is equal to AB vector by mod AB vector. Why we are writing like this? Because we know that AB vector has two parts. The one is magnitude and another is direction. So if we have to find the direction, just transfer this part to the left side and you will get AB vector by mod of AB. Is this clear?
Yes, sir.
Very good. So we can write AB cap as, this will be AB vector, and we need mod AB. Mod AB we can find, which is 2 square plus 3 square plus 4 square, and we just got it as root 29. And AB vector by mod of AB vector. AB vector is 2i plus 3j plus 4k cap, and 2i cap, 3j cap, 4k cap, and mod AB is root 29. So we'll get 2 by root 29 I cap plus 3 by root 29 j cap plus 4 by root 29 k cap. This is the unit vector of the given vector AB. Are you clear how to find it?
Yes, sir.
And what unit vector signifies? Unit vector signifies the direction, and unit vector in another terms you can define it as the vector whose magnitude is unity. The vector whose magnitude is unity. Magnitude is unity. Unity means just 1. That means 1. Note all this. Now we have idea that what are vectors, why we are studying, because they are consistently used in quantities that are popularly used in physics. Then we discussed how to represent a vector. Then we discussed how to find the magnitude of vector. Now we discussed direction, how to find the direction of a vector. Noted?
No, sir. 1 minute.
Okay. Done.
Yes, sir.
Okay. Now you can find the unit vector and magnitude for any vector, or have doubt?
I can find, sir.
Very good. Let's go further. The next important concept that we have to go through is position vectors. Position vectors. What are position vectors? If we have something like this coordinate axis and let this point to be P, and coordinates are x1, y1 and z1. Consider it here, and coordinates x2, y2 and z2. This is OP, this is OQ. So when we are given somewhere position, or say the coordinates of any point, we can convert them in form of vectors, that is called position vectors. Position was given, we are converting it in terms of vectors. So position vectors of point P would be what? This will be OP vector. Clear? And OP vector would be x1 units towards y, y1 units towards x1 units towards x-axis, y1 units towards y-axis, and z1 units towards z-axis. So we'll get x1 I cap, y1 j cap plus z1 k cap. Correct? Similarly, position vector, are you getting this part?
Yes, sir.
Okay. So position vector of point Q, answer what it would be? What it will be? OQ vector. Hello.
Sir, x2 I cap plus y2 j cap plus z2 k cap.
Very good. So x2 I cap, y2 j cap plus z2 k cap. So we have idea about the position vectors now, that if we have somewhere point, we can convert it in terms of vectors. That means position vectors. In the same question, if I ask you, can you find the vector for PQ? PQ vector? Or can you find the QP vector? QP vector. If I say PQ vector, that means from P to Q. This is called PQ vector. If I am saying QP vector, that means here is somewhere P, here is somewhere Q. From Q to P, this is called QP vector. So there is difference. PQ vector means from P to Q. QP vector means from Q to P. So PQ vector would be what? Can you find? No.
No. No, sir.
Okay. So there is concept that if you have to find PQ vector and you know the position vectors of those 2 points, just use the final minus initial. Final is what? The Q, and initial is P. So do OQ minus OP. This is triangle rule of vector addition actually. I will just show. OQ minus OP. OQ is x2I plus y2j plus z2k minus x1I plus y1j plus z1k cap. And finally we'll get what? Finally we'll get x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is the PQ vector. Anywhere doubt?
No, sir.
Similarly, if I ask you, can you find for the QP vector? Yes.
Yes, sir.
It will be?
x2 minus x1 I cap.
No. Final minus initial. That means OP vector minus OQ vector. OP is what? OP is x1 I cap plus y1 j cap plus z1 k cap and minus x2 I cap plus y2 j cap plus z2 k cap, and if I subtract it, I'll get x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. Can I write like this?
Yes, sir.
You are very clear with this?
Yes, sir.
Okay. So if you have somewhere point R and there is point S and I ask you to find RS, you will do what? OS minus OR. If I ask you to find SR, then what you will do? Final minus initial. OR minus OS. Is this clear?
Yes, sir.
Note all this. This is the position vector concept. And after getting the exact vectors for OP, OQ, PQ or QP, we can very easily find its magnitude and the directions when required, because we know how to find the magnitude. So now we'll discuss the magnitude and direction for position vectors. Not just position vectors, the vectors that we have got as PQ and QP. Position vector just means that there is somewhere position, or say the coordinates are given. We are just writing them in terms of vectors, nothing else. Noted.
1 second, sir.
Okay.
Done, sir.
Okay. Can I remove this?
Yes, sir.
Okay. If we have, suppose, point P as 1, 2, 3, and there is point Q as 4, 6, and 7, and I ask you to find PQ vector, find it. Hello.
Yes, sir.
Oh yes, yes, yes.
Okay.
Okay. Hmm. Saturday, yes. Okay, I'll check and confirm. Okay, okay, sure. Okay, that's okay. Hello. Done this question?
Yes, sir.
It is what?
Yes, what? Sir, 3 I cap plus 4 J cap plus 4 K cap.
3 I cap plus 4 J cap plus 4 K cap. What you did?
Sir, 4 minus 1
4
I cap
minus
plus
1,
6
x2 minus x1, y2 minus y1, and z2 minus z1. Why? Because the concept says that PQ is equal to OQ vector minus OP vector. OQ vector is 4i cap, 6j cap, 7k cap, and OP vector is what? 1i cap, that means just I cap plus 2j cap plus 3k cap, and if I subtract it, I'll get 3i plus 4j plus 4k. If I ask you to find PQ mod, that means the magnitude, and I ask you to find PQ cap, can you find it? Can you find the magnitude and direction?
Yes, sir.
Find. What you will do for mod PQ? 3 square plus 4 square plus 4 square, that means 9 plus 16 plus 16. It will give us root of 41, correct or doubt?
Yes, sir.
And for PQ cap, it will be PQ vector by mod of PQ, that means 3i cap plus 4j cap plus 4 k cap divided by root 41. This means 3 by root 41 I cap plus 4 by root 41 j cap plus 4 by root 41 k cap. This is our PQ cap. Note this part.
Yes, sir.
Noted. Okay, very good.
Yes, sir.
Now I'll just explain a logic that why we did PQ vector, because this might arise that why we are doing like this OQ minus OP. What is the reason? There is a parallelogram of vector addition which says that if you have a parallelogram like this, there is a vector, and if you join the starting point and the ending point of the second vector, polygon rule, also the parallelogram rule, this will give you the sum. If this is A vector, this is B vector, then the diagonal will give you A plus B vector. This is the concept. That means if I name it A, B and C, that means AB vector plus BC vector is equal to AC vector. And it is not like that it happens only in cases of triangle, it happens in any cases. If you have something like vectors like this, you join the starting point and the ending point, it will give you the sum. If it is A vector, B vector, C vector, you'll get it as A vector plus B vector plus C vector. Clear? This is the addition method. Polygon rule of vector addition, you can say. And here AB vector plus BC vector is equal to AC vector based on the same concept we are writing. So if I have to find somewhere, suppose BC vector, what I can write? I can write AC vector minus AB vector. What I can observe here? I can observe that whenever I have to find BC vector, so this is final for the C part, and here initially it was B, so initial, this kind, AB. Similarly, if we have point P and point Q, I am joining this part OP, I am joining this part OQ, and if I have to find PQ vector, then PQ vector, what I can see here, that OP vector, this is OP vector, this is going in same direction, PQ is going in same direction, OP vector plus PQ vector will be equal to what? OQ vector. By applying the same logic, can I write like this?
Yes, sir.
I have joined the initial and I have joined the final. So OQ vector is the summation of the OP and PQ. So if I have to find PQ, what I am getting actually? OQ vector minus OP vector. This is the reason. But if you want to remember, you can directly write final minus initial. If I have to find PQ, I'll write OQ minus OP. If I have to find RS, OS minus OR. Note this concept. You are following which book? NCRT or some other also?
NCRT, sir.
NCRT, okay. Noted.
Yes, sir.
So if you see the first exercise of the vector topic from NCRT, you'll get some very basic kind of questions like which is scalar quantity, which is vector quantity, what are the magnitude, what are the directions, this kind. One thing that we haven't discussed yet, you can take it as an example, as I can see in your first exercise. Suppose you have somewhere this kind of force. Here there is an object and force is applied in this direction and it is 30 degree. We are very clear that if some vector is given in terms of I, j, k, I can find the unit vector and get the direction, right? But if some vector is given in by just representing this direction and by f, this kind, so what we can say, as in example they have given it as 40 kilometer, not just f, they have given 40 kilometer. So what we can write in terms of east, west, north and south? Can you write this in terms of east, west, north, south? You can say 40 kilometer towards west, right? West of south. And how many degrees west? 30 degree west of south. Is this clear?
Yes, sir.
This is the way to write. If we have somewhere like this, suppose here, and this angle, suppose this angle is suppose 75 degree, what you will say, and this, suppose this is your 35 kilometer, you will write it as 35 kilometer east, 75 degree east of north. Is this clear?
Yes, sir.
Okay, in this way we can write. That's it. This is the basic idea, and on these concepts I think you can solve almost all the questions from the first exercise. Let's go further. Okay, there are few more concepts also, like the terms, the unit vector we are clear, the zero vector, co-initial vector, co-linear vectors. Let's discuss them also. Note this part, note this. Noted?
Yes, sir.
Okay. What are zero vectors? Zero vector means
Sir,
what?
zero vector with
Zero vector means? Hello? Answer?
yes, sir. If the magnitude and direction is zero, then it is called as zero vector.
Magnitude is zero. That is enough, right? Direction need not to be zero. If it is a point zero, there is nothing. So there is no sense of making any conclusion about the direction, right? Zero vectors are those whose magnitude are unity. Magnitude is what? Zero. Clear? If I say co-initial vectors, co-initial vectors, and zero vector can be written as zero vector. Zero vector means 0 I cap, 0 j cap, 0 k cap. This is the concept. Co-initial vectors. This means what? Co-initial vectors. Co-initial vector, tell.
Sir, when two vectors have when two vectors have the same starting point,
Very good.
called as
That is enough.
co-initial vector.
We have a vector this, we have a vector this. O, P, Q. OP and OQ are co-initial vectors. Clear? I can make one more vector R. OR vector is also a co-initial vector. Similarly, there is a term in your NCERT which says collinear vectors. Collinear vectors. This means what?
Sir, if two vectors are parallel to each other.
Yes, we can say.
then
We can say.
yes,
And
whole.
from here, you should draw one thing, one conclusion about the vectors. If you have somewhere vector AB here, it is not like that it can be written, it can be represented here only. You can shift wherever you want, right? You can shift it here also. If some vector is given here, this and this, if you want, you can shift this particular vector to this part. That means it is movable, but direction and length should not change. It is not like that if some vector is in this direction, you will change the direction. You can't change the direction, but you can shift it accordingly. Is this clear?
Yes, sir.
Okay, that means movable. That's it. But direction and length should not change unless it is specified in some question that the length is doubled, or say the magnitude is doubled. This kind of information if given, then we can do. The direction is opposite, then if AB is in this direction, obviously the if we are taking some PQ vector and it is in opposite direction, PQ will look like this. Okay, so
Yes,
whenever
sir.
two vectors, if they are parallel, we can say they are collinear. Suppose we have a vector AB, this is AB, and we have a vector PQ. Suppose here P and here Q. So we can say this AB and PQ vectors are collinear vectors, or say AB and AP are collinear vectors. Okay. There is also one term,
Yes, sir.
I think it has not been mentioned in your NCERT, but it is important. Like vectors and unlike vectors. Like vectors. What are like vectors? What are like vectors?
The vectors having the same magnitude and direction.
Same magnitude also. Just same direction is
No,
enough.
same direction and different magnitude.
No, it is not. There is no information about the magnitude. Magnitude can be equal and cannot be equal. Like vector means they have just same direction, right? If there is AB vector in this direction and PQ vector in this direction, we can say it as they are like vectors. Okay, same directions. Note all this. What are unlike vectors?
Sir, vectors having different direction.
Yes, opposite direction. Opposite is important. Unlike unlike vectors. So for unlike vectors, if we have AB vector here, we have somewhere PQ vector. So I can say that AB vector and PQ vectors are unlike vectors. Their directions are opposite to each other, right? Opposite directions. Note this also. Noted?
Yes, sir.
Okay. What are equal vectors? When you say two
Sir,
vectors as equal,
vectors having the same magnitude.
same magnitude, and that is enough.
The same magnitude and same direction.
Yes, same direction also. then you can say they are equal. So you have to observe for both. Negative of a vector, negative of a vector,
Sir, when a vector in which we change the direction to the
yes,
opposite direction
this is
equal
AB
to that.
vector, this is AB vector. If I have, this is actually what, AB vector. If I have to represent minus AB vector, I can just change the direction, right? Or doubt?
Out. No, sir.
Okay, let's go further. Note this part. Now you'd be able to solve the first exercise from NCERT very easily, and from the second exercise also many questions, as we have discussed about the position vectors, unit vectors, magnitude. So you will be able to solve approximately half of the questions if you apply the logic. Let's do one more question from the second exercise. Noted?
Yes, sir.
If you see question number 9, it says there is a vector A which is 2i cap minus j cap plus 2k cap, and there is vector B which is minus I cap plus j cap minus k cap, and you are asked to find the magnitude and direction of A vector plus B vector. Find it. So if we are adding any two vectors in terms of I, j, k, just add the I with I, j with j, and k with k. You'll get the A plus B vector. So in this question, our first task would be what? To find a new vector, let it be R, which is A vector plus B vector, right?
Yes, sir.
And it will be what? What we are getting? Hello.
Sir, I cap plus 0 j cap
Very good.
plus 1 k cap.
So I cap plus 0 j cap and plus 1 k cap, that means just k cap. If we want, we can write 1 also, there is no issue in that. So this is our R vector, and then we have to find what? Magnitude of A plus B, that means we have to find mod R. So mod R would be what?
Sir, root 2.
Yes, 1 square plus 0 square plus 1 square, this is root 2. This is the answer. And we have to find one more thing, R cap. So it would be
Sir, I cap by root 2 plus j cap by, plus 0 plus k cap by root 2.
yes, 0 j cap plus k cap by root 2, and finally we can write it as r cap equals, we can take either 1 by root 2 common, I plus k. Okay, we can write like this, or if we want we can write like this also, 1 by root 2 I cap plus 1 by root 2 k cap, but it will be preferred. I think the answer should be in this format. Note this part. You solve only NCERT or some other book also?
Sir, only NCERT.
Only NCERT. No other book has been recommended by your school?
No, sir.
Okay, that's okay. But we'll solve RS Agrawal also, because in NCERT there is very less number of questions. Okay, so we need practice in maths at least. So we'll be following NCERT. We'll do the questions from NCERT and RS Agrawal both. In this way, we'll do a lot of questions. Noted?
Yes, sir.
Okay. So for today, we can just keep up till here. We'll discuss further in the next class. Your homework is do the first and second exercise of the NCERT. Okay. And if possible, you can download the RS Agrawal, or if required, I can share you the questions also. Okay.
Okay, sir.
You obviously have enough time to practice it. Okay. We'll discuss further in next class. Are you clear with all the concept that we discussed today?
Yes, sir.
Okay. Okay then.
Okay, sir.